Imagine for a moment that we have spent centuries looking for the secrets of life in all the wrong places. We peered through telescopes at distant star systems. We dove into the deepest tropical trenches, and we scanned the vast rainforests of the Amazon. But in the year 2026, a team of international researchers operating in the most desolate, frozen reaches of the Arctic Circle stumbled upon something that has effectively hit the reset button on our understanding of biology. This isn't just a new species of fish or a strange prehistoric bacteria found in the melting permafrost. Deep beneath the tectonic plates of the Arctic Ocean, in a realm of crushing pressure and absolute darkness where we previously believed life was physically impossible, a massive interconnected biological network has been discovered. It is a world that doesn't rely on the sun, doesn't follow the rules of the food chain as we know it, and suggests that the very origins of life on Earth might have happened in the cold, dark basement of our planet rather than the warm, sunny surface. This 2026 discovery is so massive that it doesn't just change the textbooks, it rewrites the entire story of how we, and everything else on this planet, came to be. To understand why this is such a shock to the system, we have to look at what we thought we knew about the Arctic. For decades, the Arctic was seen as a biological desert. The water is near freezing. The ice cover blocks out the sunlight for half the year, and the nutrients are scarce. Traditional science told us that life needs a few basic things: liquid water, an energy source, usually the sun through photosynthesis, and carbon. We thought that away from the hydrothermal vents, the deep ocean floor was a quiet, empty graveyard. But in early 2026, using a new generation of autonomous deep-sea submersibles, equipped with advanced sonar and chemical sensors, scientists began to pick up a strange rhythmic pulse coming from the seabed near the Gackle Ridge. It wasn't seismic activity, and it wasn't a mechanical echo. It was a chemical signature of breathing. When the submersibles reached the source, they didn't find a few stray organisms. They found a gargantuan, living carpet of specialized cellular structures that stretch for hundreds of square miles. These aren't plants, and they aren't quite animals. They are something entirely new to science, a form of life that researchers are calling lithobionts. These organisms don't eat plants or other animals. Instead, they have developed a way to directly harvest energy from the slow, grinding friction of tectonic plates. In the year 2026, we discovered that the Earth itself is the battery for this massive ecosystem. The heat and chemical reactions caused by the movement of the Earth's crust provide a constant, infinite source of energy that has allowed this hidden world to thrive in total isolation for perhaps billions of years. This discovery flips our understanding of the habitable zone on its head. Usually, when astronomers look for life on other planets, they look for worlds that are just the right distance from their sun to have liquid water on the surface. But if life can thrive deep under the crust of a frozen ocean by tapping into planetary friction, then suddenly, almost every moon and planet in our solar system becomes a candidate for life. Jupiter's moon Europa and Saturn's moon Enceladus both have frozen shells and active interiors. What we found in the Arctic in 2026 is the missing link that proves life doesn't need a sun to create a complex, thriving civilization of organisms. It suggests that the universe might be far more crowded than we ever dared to imagine, with life hiding comfortably in the warm, dark bellies of frozen worlds. But the most mind-blowing part of the 2026 Arctic discovery is the way these organisms communicate. We always thought of deep-sea life as being primitive or solitary. However, the lithobiont carpet is connected by a global network of biological wires, long filaments of superconducting proteins that allow different parts of the colony to share information and resources over thousands of miles. It is effectively a biological internet that was operational billions of years before humans ever existed. If one part of the colony finds a rich vein of minerals, it sends a chemical and electrical signal through the network, and the entire colony shifts its growth pattern toward that resource. It is a collective intelligence that operates on a scale we can barely fathom. It makes us realize that intelligence in nature doesn't always require a brain or a central nervous system. Sometimes, it's a distributed network of billion-year-old cells working in perfect harmony. The chemical makeup of these organisms is another huge shock for the year 2026. Every form of life we knew before this discovery was based on a very specific set of 20 amino acids. These Arctic organisms use a completely different set of building blocks. Their DNA structure is not a double helix, but a triple braid configuration that is incredibly resistant to the high pressure and extreme cold of the deep Arctic. This suggests that life on Earth didn't just happen once in one specific way. It implies a second genesis, a completely separate branch of the tree of life that has been growing right under our noses for eons. It's like finding out you have a secret twin brother living in the basement who speaks a language you've never heard and has a completely different biology. This discovery also changes how we think about the history of our planet. For a long time, we believed that life started in Darwin's warm little pond, shallow, sun-drenched tidal pools where chemicals got mixed by the waves. But the geological evidence from the 2026 Arctic mission suggests that the lithobiont network is actually much older than any surface life. The fossils found in the rock layers beneath the living carpet date back nearly 4 billion years. This leads to a radical new theory. Life didn't start on the surface and move down. It started in the deep, pressurized cracks of the Earth's crust and eventually moved up. We might be the outsiders, the descendants of a few adventurous cells that left the safety and stability of the deep Earth to colonize the harsh, radiation-filled environment of the surface. As we move deeper into the data from the year 2026, we are realizing that this hidden ocean of life plays a massive role in our global climate. We always wondered where a huge chunk of the Earth's carbon was being stored. We couldn't account for it in the forests or the surface oceans. Now we know. This massive biological network is a giant carbon sponge. It breathes in carbon that is released from the Earth's mantle and stores it in a stable, mineralized form. In the year 2026, we discovered that without this hidden Arctic ecosystem, the Earth's atmosphere would have become toxic and overheated millions of years ago. These organisms are the silent janitors of our planet, keeping the balance of gases just right so that we can breathe on the surface. Furthermore, the medical implications of the proteins found in these lithobionts are staggering. Because they live in such extreme conditions, their enzymes are capable of repairing DNA damage at a rate that is nearly 1,000 times faster than human cells. In the year 2026, pharmaceutical companies and research labs are already scrambling to understand how these biomortality proteins work. If we can adapt even a fraction of their self-repair mechanisms for human use, we could potentially solve some of our most difficult health challenges. We found a pharmacy of the future buried under the ice of the past. The way we conduct science has also been transformed. Before the year 2026 discovery, deep-sea exploration was seen as a luxury or a niche interest. Now it has become a matter of existential importance. Governments around the world are pouring billions into inner space programs. We realize that we know more about the surface of the moon than we do about the life-sustaining machinery beneath our own oceans. The 2026 discovery has triggered a new iSpace race. But the destination isn't the stars, it's the seabed. Every nation wants a piece of the genetic and chemical secrets hidden in the Arctic. However, this discovery also comes with a heavy warning. The Arctic ice, which has acted as a protective shield for this ecosystem for millions of years, is melting. As the ice disappears, the water temperature changes, and the pressure balance on the seafloor begins to shift. In the year 2026, we realized that we might be in the middle of a race against time. If we don't protect the Arctic environment, we might lose the very network that keeps our atmosphere stable before we even fully understand how it works. It's like finding the most important book in the world while the library is on fire. The sheer scale of the lithobiont network is hard for the human mind to grasp. Imagine an organism that isn't measured in inches or feet, but in whole degrees of latitude. When we look at the Arctic in 2026, we are seeing a single living entity that is larger than any forest or coral reef on the surface. It is a superorganism that treats the entire Arctic basin as its home. This forces us to reconsider what individuality means in nature. Are we truly separate beings? Or are we just small parts of a much larger, global biological machine that we are only now beginning to perceive? The technology used to find this life is just as impressive as the life itself. In the year 2026, we saw the debut of neuromorphic sonar. Traditional sonar just sends out a beep and listens for the bounce. Neuromorphic sonar uses a synthetic brain to interpret the echoes, allowing it to see the difference between a rock and a biological structure with incredible detail. This tech allowed us to see through the sediment and realize that what we thought was just a rocky ridge was actually a ribcage-like structure of a massive colony. It was a victory of human ingenuity that allowed us to bridge the gap between our world and the alien world beneath us. As the year 2026 progresses, the debate over this discovery is taking over every major scientific conference. Some researchers are calling for a complete moratorium on deep-sea mining in the Arctic. They argue that the litho-biont network is too fragile and too important to risk. Others argue that the minerals and the genetic data we can harvest from this site could save our civilization from its energy and health crises. It is a tension between the need for resources and the need for preservation that will define the rest of the 21st century. The year 2026 is the year we finally had to face the fact that our planet is far more complex and far more alive than we ever gave it credit for. Consider the deep water cycle. For a long time, we thought water just went from the ocean to the clouds and back. But the 2026 data shows that these deep organisms are actually pumping water into the Earth's crust and filtering it through their biological membranes. They are part of a geological-scale water purification system. They remove toxins and heavy metals from the water that eventually makes its way back into the surface oceans through hydrothermal vents. It's a closed-loop system of planetary health that has been running on autopilot for billions of years. We are the beneficiaries of a service we didn't even know existed until now. What does this mean for our sense of place in the universe? In the year 2026, we are feeling a strange mix of humility and excitement. We used to think we were the apex of life on Earth. We were the smart ones, the complex ones, the ones at the top of the pyramid. But the Arctic discovery shows us that there is a form of life that is older, more resilient, more interconnected, and perhaps wiser in its stability than we are. It's a humbling lesson that suggests we are just one part of a very large and very ancient family. It reminds us that Earth is not our playground. It is a shared vessel with passengers we are only just meeting. The study of the lithobionts is also giving us clues about shadow biospheres. This is the idea that there might be other types of life on our planet that use different chemistries or exist in different dimensions of scale that we simply haven't learned how to detect yet. The year 2026 Arctic discovery proved that you can have a massive amount of biomass right in front of you, but if you aren't looking for the right chemical signatures or using the right sensors, it will remain invisible. It makes us wonder what else is hiding in plain sight. What is in the deep crust under our cities? What is in the high atmosphere that we misidentify as dust? As scientists in the year 2026 continue to sample the triple-braid DNA of the Arctic organisms, they are finding sequences that are unlike anything else. Some of these sequences seem to be able to store data in a way that is far more efficient than our current silicon-based computers. This has led to the emergence of biocomputing as a new field. We are looking at ways to use the biological logic of these organisms to build a new generation of computers that don't need electricity and can grow and repair themselves. The year 2026 is the year that biology and computer science officially merged into a single pursuit. The mission commanders of the Arctic expedition often speak about the eerie peace of the deep. Down there is no noise, no light, and no seasons. The lithobionts have existed in a state of tranquil stability while the surface world went through ice ages, asteroid impacts, and mass extinctions. They are the ultimate survivors. Their existence in 2026 serves as a reminder that the most durable things in the universe are often the ones that are the most connected and the least flashy. They don't need to conquer, they just need to exist and cooperate. The geological impact of this life form is also being mapped. As the lithobiont carpet grows, it actually alters the chemical composition of the rock beneath it. It turns hard basalt into a softer, more porous substrate. In the year 2026, geologists realized that this biological action might actually be what triggers certain types of slow-slip earthquakes. Life is literally moving the mountains and shifting the seas. The Earth is not just a rocky ball that life happens to live on. The Earth is a rocky ball that is being shaped and reshaped by life at every level, from the highest peak to the deepest trench. Some of the younger scientists on the 2026 team are referring to the discovery as nature's time machine. Because these organisms grow so slowly and live so long, some of the individual cells being sampled today might have been alive when the first dinosaurs appeared. Their DNA is a record of the Earth's history in a way that no rock or ice core could ever be. By reading their triple braid code, we are getting a year-by-year account of the Earth's chemical history over millions of years. It's an archive of the planet's life, kept in the deep freezer of the North. As we look toward the future from the vantage point of 2026, the path ahead is clear. We have to become better stewards of this planet. We can no longer act like we are the only important residents. The 2026 discovery has given us a new sense of responsibility. If we disrupt the lithobiont network, the consequences could ripple through the entire planetary system, affecting the air we breathe and the stability of the crust we walk on. It is a terrifying thought, but it's also an empowering one. We now know what we need to protect. The year 2026 will be remembered as the year the invisible world became visible. It started with a strange pulse under the Arctic ice and ended with a total transformation of our identity as a species. We are no longer alone on this planet, and we are no longer separate from its geological processes. We are part of a deep, ancient, and beautiful system that we are only just starting to appreciate. The ice is melting, the submersibles are diving, and the story of life is getting a whole new set of chapters. When the researchers finally brought the first living samples to the surface in specialized high-pressure tanks, they noticed something poetic. Even though the organisms came from a world of darkness, they began to emit a soft, bioluminescent glow in response to certain sounds. It was as if they were trying to communicate back. The year 2026 discovery wasn't just about finding life, it was about beginning a conversation that will last for generations. We found a neighbor in the deep, and in doing so, we found a better way to understand ourselves. The discovery has also sparked a cultural revolution. Artists, writers, and philosophers are using the lithobiont network as a metaphor for a new kind of human society, one that is more horizontal, more resilient, and more focused on deep stability rather than superficial growth. The year 2026 is a milestone in our intellectual history. We are moving away from the exploitation mindset and toward the symbiosis mindset. We are realizing that the best way to thrive is to be part of a network that supports everyone. In the final reports from the 2026 mission, the lead scientist wrote that the Arctic floor is not a graveyard, but a nursery. It is where the Earth takes care of its oldest and most delicate creations. It is a place of wonder and mystery that has stood the test of time. As the world watches the news in the year 2026, people are stopping to look at the ground beneath their feet with a new sense of awe. They are realizing that there is an ocean of life just a few hundred miles down, and it has been there all along, waiting for us to be ready to see it. The year 2026 is just the beginning. The submersibles are going deeper, the sensors are getting more sensitive, and the triple braid DNA is revealing more of its secrets. Every day we learn something new that challenges our assumptions and expands our horizons. The Arctic discovery has opened a door that can never be closed again. We are the generation that finally looked into the deep and found a reflection of the entire universe. As we think about the future, we have to keep the lessons of the lithobionts in mind. Connect, conserve, and cooperate. Those are the rules of the oldest life on Earth, and they are the rules that will allow us to survive the challenges of the 21st century. The year 2026 gave us the map to a new understanding of life. Now it's up to us to follow it. The deep Arctic is no longer a world of ice and silence. It is a world of life and song, a world that has finally been brought into the light. Stay curious, stay humble, and remember that the most important discoveries are often the ones that were hiding in the darkest places. The year 2026 changed everything, and yet, in many ways, it only confirmed what the Earth has been trying to tell us for billions of years. Life is everywhere, life is ancient, and life is one. The submersibles will continue their work, and the researchers will stay in their labs. The headlines will move on to other things, but the legacy of the year 2026 Arctic discovery will remain. It is the foundation for a new era of biology, a new era of space exploration, and a new era of human consciousness. We are living in a remarkable time, and the discovery under the ice is the greatest proof of that. The journey is far from over. But for the first time in history, we know the true scale of the world we call home. It's a blue planet, yes, but it's a deep, living one, and that makes all the difference. The year 2026 started a revolution in the cold, and its heat will be felt for centuries to come.